This is a video that will help you go over your homework from Friday on side, 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 and side angle side. So this will help us study for our quiz. So the first 6 problems, you had to decide if congruent, by what method, and write a congruent statement. So in problem 1, all 3 pairs of sides were marked, so side, side, side. And then a congruent statement is stating which 2 triangles are congruent. And remember, there are 3 ways that you could write a congruent statement. So if yours isn't exactly in this order, just make sure that the corresponding parts match up. Number 2 is side angle side, and you may have put none, but the key to looking at this is that you have the arrows here. That means we have parallel lines and a transversal. So you can mark alternate interior angles to go between the 2 given sides, so you have side angle side. For problem number 3, you wanted to mark the shared side TS to make it side angle side. So it's really important that you make all the markings on each diagram. For number 4, again, you have a shared side QN, therefore we have side, side, side. For problem number 5, you could mark the vertical angles just to check. So those are vertical angles, but the problem is that still gives us ASS, not SAS. And remember, we don't have any donkeys, so no ASS theorem. And then for number 6, we mark the shared side XZ, so you have side angle side. So now we'll go over the proofs, and there will be 2 of these on your quiz. So we always want to start with what's given, and we also want to keep track and mark the diagram as well. So segment AM is congruent to CP, that's given. Oops, AM and CP. CM is congruent to GP. Again, that's given. And then C is the midpoint of AG, and that was given. And because C is a midpoint, so we're looking at segment AG right here, that whole segment, if C is the midpoint, that means segment AC is going to be congruent to CG. And that's the last piece of information that we needed, and that's definition of midpoint. And then we always end with what we're trying to prove. So triangle ACM is congruent to triangle CGP by side, side, side. So again, marking the diagram is crucial to making your proof easier to do. Okay, number 8. PQ is congruent to RS. Given. Angle PQR. So remember, the middle letter tells you where the vertex is, and that's where the arc goes. So PQR, SRQ, and that's given. And then all we have is side angle. So that should tell us that we need another side, and we are allowed to mark a shared side QR. So QR is congruent to itself, and that's reflexive property. And then that's enough to prove PQR is congruent to triangle SRQ by side angle side. Now number 9 gets a little longer because there's a lot going on, and this is a critical piece of information right here. So we'll start with side AB is congruent to side DE, and that's given. AB is parallel to DE. When you see that you have parallel sides, this is a sign that you're going to have congruent angles. So that's going to be a hint, congruent angles. The key is, where are those angles? So if AB is parallel to DE, let's take it and extend the drawing a little further. So those would be our parallel lines. And then we have a transversal going that way. So what that'll create is alternate interior angles. And then we have C as the midpoint of AE. So that means AC and CE will be congruent. So this is given, the first three. We know that AC is congruent to CE by definition of midpoint. And then we can go back to the parallel, and I marked the alternate interior angles, so angle BAC and angle DEC, and that's by alternate interior angles. And then that's enough to show side, angle, side. And then our final proof, segment WX is congruent to XZ, or YX, excuse me. That's given. WX bisects angle W or YXZ. So again, make sure you know which angle is actually being cut in half. So this angle is being bisected by segment WX. So what that means is these two angles are congruent. So I'm going to start out with WX bisects angle YXZ. And because of that, by definition, angle WXZ is going to be congruent to angle WXY. And that is by definition of angle bisector. And then we have a side and an angle. So we have a side and angle. So obviously we need another side. And we look at the drawing and see that Y or WX is so WX is congruent to itself. Reflexive property. And triangle WYX is congruent to WZX by side, angle, side.